Yeah, I was reading that last name for a long time.
It's pretty
Text
interesting.
the president very thorough.
Yeah, that's pretty interesting.
Yeah, that was interesting.
I texted Michelle
Yeah,
to remind her, so. Should we get started?
so.
You ready, Pam? All right, I will call this special meeting of the Ridgway County Council Monday, June 2nd. There she is. June 2nd, 2025. I'll call the meeting to order.
Counselor Scrambley,
Here.
Kroger,
Here.
Montague,
Here.
Schuyler,
Here.
Scoville, here. Favorite Tim Lincoln,
Here.
Mayor Clark.
Here. All right, as I said, this is a special meeting to review, discuss, and get direction on the existing conditions and alternatives analysis with Beaver Creek Diversion Restoration Project. Spec.
Yeah, I'll kick it off, Mayor. That's all right with you. Thank you, everyone, for making time today. Really appreciate it. Sorry for the wishy-washiness and getting this scheduled, but again, I know Paulie's out of town and we all have plenty of other things going on, but thank you for making the time. I hope everyone had a chance to at least skim the memorandum, the existing conditions and alternatives analysis memo that Respect worked really hard to put together over the last few weeks. And I know it was a dwindled time frame compared to what you guys are used to. So thank you for putting some attention to it. It does a really good job of documenting the existing conditions of the diversion site, laying out alternatives for diversion location and also for the ultimate design for the diversion. And it includes a recommended diversion location and design to proceed with, subject to town council concurrence, which is why we're here tonight. So what we're looking for today is direction, not action. We're looking for agreement and buy-in on a concept that we can start to further to eventually get to construction level documents and so that we can get the appropriate environmental and legal clearances in place as well. So we have Alan Leak and Michelle Hopkins with Respect here with us. They're on Zoom. I'll turn it over to Alan so that he can highlight, or maybe it's Michelle, but I think it's Alan, to highlight the high points of the analysis and reinforce the recommendation that you all read in the memo. And they can help answer any questions you all may have about the existing conditions, the analysis itself, or maybe beyond. So I hope that makes sense. And Alan, I'll turn it over to you.
Sounds good, Preston. Again, I'm Alan Leak, the principal in charge of this project for Respec. Michelle Hopkins, our project manager, is also on the line. We thank the town council for providing us a time to just very briefly walk through our alternatives report and that. Again, I'm not going to spend a lot of time into the details. I'm just going to highlight the high points of the report itself. And certainly once I get done, we're certainly open for questions and answers to answer anything that you may have that you would like to know prior to giving us direction as far as how you would like us to move forward. I've got a very short PowerPoint that I'm going to try to share. I'm hoping that this works, but let's give this a shot here and see what happens.
We see it, Alan.
All right, you still see it?
Yes, sir.
All right. So again, I think we're all aware of the damage that was done in the August 2021 event. What I really want to do is highlight from an engineering perspective what is important in the development of this project itself. This is just a slide, again, providing everybody an overall view of Beaver Creek and the existing diversion location. North is to your right. And what I really want to just highlight again is, the existing or the original push-up dam, which allowed water to flow over to a side channel, go over the Grizzly screen as a diversion, and then into the sloop and bypass channel and open ditch on down. And then that ditch also picked up the spring diversion pipe that you see on here. The August 2024 events characterized by both cycles of what I call aggradation and degradation in a dynamic geomorphic system. We had the initial erosion and degradation occurred during the high flows of the event. And then as the flow subsided, you started to get the deposition of small boulders, cobbles, fine sediments in the receding limb of the event itself. The diversion channel and the structure was filled with 3 to 4 feet of material, while the adjacent channel degraded about 3 or 4 feet. So this is the adjacent channel that you're seeing here before and after. And although the scale doesn't really show it, this channel over on the right-hand side is about 3 or 4 foot lower than it was historically. This is a view looking downstream from where the push-up dam was. On your left-hand side is the main channel of Beaver Creek. On the right-hand side was the diversion channel or side channel that took flow over to the grizzly structure itself. And the picture on the right is just an example of the bank erosion that occurred during the event itself. Again, on the right-hand side is the original grizzly before the event. On the left-hand side, you can see that it's filled with 3 to 4 feet of sediment and just completely buried. This is the existing sluice that existed downstream from the structure and the bypass that would allow sediments in that to be sluiced back to the creek, and flows that exceeded what you wanted to carry in the ditch to go back to the creek itself. And of course, after it, this is exactly what it looked like. It was completely filled up with sediment and debris from the event itself. You know, we don't yet have an estimated frequency of the event, but likely believe that it was larger than a 100-year event and was bulked with sediments in that, which can double the amount of flow or size of flow that the channel would have seen itself. So for the alternatives analysis, we looked at a lot of different locations and kind of came down to 3 possible locations. One is the one up on top with north being to the top, which is where the existing grizzly diversion structure was. 2, we looked at the about 200 feet upstream, which is about where the push-up dam was located to divert water over into the side channel. We also looked at it about 800 feet upstream, all looking to try to figure out what would be the most stable and best location for a future diversion structure. And really what's most important to select a site is one that has the most relative stability and control while meeting the project objectives. So I'm going to go through a couple of the alternatives that we really focused on. The one 800 feet upstream, although is a more stable channel section, it did not meet the other project goals from a water rights standpoint, from total disturbance standpoint of trying to build something that far upstream. And so we really focused on the 2 downstream locations itself. The first one would be trying to put it back in the same location. And again, these are just concept plans that we use to help develop just some conceptual cost estimates. In this case, we'd be working on a structure to try to divert up to 10 CFS over into the side channel itself. But higher flows than that, we really don't want to go into the side channel. We'd want to try and maintain those into the main stream itself. So this kind of boulder push-up dam with high flow bypass is what we had conceptually looked at. We're going to have to stabilize the bank of that side channel itself. We could either remove and replace the grizzly with a larger structure or a different type of intake itself, but then tie back into the existing facilities that are there, assuming that we can get them cleaned out and everything tied back together. So some of the pros of that is we can use the existing steel sluice structure there. has similar operation and maintenance as the previous design. It's probably the easiest to get access to and has the smallest area or footprint of the impact itself. The pros or the cons are the most flows directed toward the secondary channel, which is not or could be armored, but it's very difficult to armor for those flows. So then really what we want to do is to divert only 10 CFS flow over there and let the rest go down the main channel. That is a very difficult structure to try to design. And I'm going to go back here. If you think about it, we're trying to take 10 CFS around the main channel and have the rest of the flow go down the main channel. So the problem is if you have a debris flow or flow that carries a lot of sediment and boulders, it may change the ability of us to maintain the actual 10 CFS flow over to that side channel and still continue to push everything to the main channel itself. It would require a new intake structure, whether a Coanda or another Grizzly. We think it's less resilient to hold up against another debris flow, highest risk of failure, mainly because one, it's not in a real confined channel section, and two, because of the risk in trying to maintain that diversion balance between what we divert over and what we continue to have flow down the main stream itself. The channel is less stable in this location. We think that would take the highest amount of routine maintenance compared to the other alternative, just because we would still have to deal with sediment and rocks and that coming down through the facility, and we'd have to periodically maintain the diversion dam to maintain that balance of flow. It also requires the highest amount of earthwork, so what I call the highest amount of disturbance from a volumetric standpoint. The second alternative would be to build a facility about 200 feet upstream itself. This facility we just conceptualized as a Coanda screen. It may be a different type of Grizzly, but it'd be something kind of off the side of the channel and tied into the existing large boulders that are there. And then we would be piping it down from that location either through a different alignment, which we've shown here, or we could possibly take it back down through the existing steel sluice and that, just trying to maintain grades and minimize impact to the landowner itself. It would require, yes.
I think somebody had a question on the alternative one.
All right. Yes, please ask.
Actually, it applies to all of them. Just a quick question. What is the typical CFS in the main channel under normal operating conditions, normal conditions?
So it varies between, 1 CFS or that in the winter and early spring or late fall, up to, depending on, what type of storm events, this channel can be carrying 20, 30, 40 CFS of flow.
So at most you'd be diverting 25% of it under high conditions.
Correct, except in, in a real large storm event.
Thank you.
Yes. Thanks, Michelle. So when we looked at this one, the pros are we've got the intake structure right at the side part of the main channel in the stream before the channel starts braiding. We've got a controlled location to build it. We can tie in the Coanda or the diversion structure into the existing boulders. It's the most stable channel location that we could find that doesn't sacrifice access. We think it would have less operation and maintenance visits as debris itself, boulders and that would go over the structure instead of into the structure. There are some risks, potential damage to the grate from boulders. We can reinforce it as kind of shown on this drawing, but there's always that risk that would damage the screen and have to be replaced. If we went with our alignment that we're showing on this figure, we'd be going away from the sluice channel itself. But certainly I think that's something as we move forward with design, we can relook at and say, can we bring it through the existing sluice location itself? It does require some significant channel armoring, as we've shown here. I believe this armoring is going to be similar to both alternatives. No matter which one we do, we still have to do some bank armoring, both upstream and downstream of the structure itself. The other thing that we put in there is a possible alternative add-on to, and this could be on either structure, and this would be an infiltration gallery. We're just showing it here, added into alternative 2, where this would be a facility that would be buried in the channel. So it would pick up any flows that's coming through the alluvial or the sands and gravels and boulders that are in the channel itself and be able to pick up that flow. The two key things for that is, one, it would definitely be able to divert that flow in the winter if the town so desired to do that. Two is that we are unsure of exactly how much underflow there's in the existing channel. It appears that the surface flow is keeping on the surface, but we won't actually know that until we dig into the alluvium and see how much subsurface flow there might be. And the concern is that if there is some of the armoring in the channel that exists right now, that as the channel tries to restore itself to prior to the debris flow conditions, may actually open up some voids and allow more surface flow into the underflow. And thus, it could be that you have, 1 or 2 CFS of surface flow that all of a sudden disappears into the alluvium, and you would not be able to divert it in a surface diversion structure itself. So I think the key thing is that we've recommended the site 200 feet upstream from the existing diversion location based on several factors. We have a reduced risk of head cut impacts. I think in the report I mentioned that there is a head cut that's heading upstream. The amount and timing of how far the head cut moves up before it's buried again with another flow is unknown, but this one's a little bit further. This structure be further upstream than the alternative 1 structure. It's naturally confined with natural confinement controls, and that's really important in being able to maintain a structure in this type of stream. The 3 other aspects that are critical to this project, but it does apply to alternative 1, is there wouldn't be a change in point of diversion required per the Division 4 water engineer. Has minimal environmental permitting risks, same as alternative 1, and minimal impact to the land as much as we can minimize. I will mention that we did take a look at different alternatives for diversion structures. We want to make sure that the diversion structure could divert a range of flows, from 0 to what was determined to be a 10 CFS as the rate for design. We think this reduces overall maintenance. It's probably one of the most naturally looking and overall appearance if you start looking at concrete structures, for example. And we think it has the minimum impacts of construction on the landowner, in other words, on the access road itself and getting materials up there. And it provides us the ability to massage the design as we kind of move forward in the process itself. So then the last thing that I want to talk about is cost. And when we look at these costs here, we really look at them as being fairly close together, and thus should not, in my opinion, be a determining factor given the current conceptual nature of this design. Because each of these has a plus or minus range, and we're not sure at the end of the day which plus or minus range each of these would end up. We do recommend the infiltration gallery be included in the final design, but the decision to install it should be made at the time that we're actually digging in the alluvium and can determine how much underflow there is. Certainly this is ability to have it in the design, and we can either implement it or not, depending what we find during construction itself. And then also, it depends if the town wants to divert water in the winter itself. We also recommend that there's some basic telemetry be added, which was in the report. This is the typical state satellite system that can be tied into that allows you to monitor the rate of diversions that are coming down the ditch itself. But that is a state-specific satellite system. So if we want additional telemetry, we'd have to look at other possible options. In total, with the above additions of an infiltration and a telemetry, our opinion of the probable construction costs will range from about 1.3 million, which is the minus 25%, to the 2.5 million, which is the plus 50% range. And that is based on a class 4 level of engineering analysis based on the Association of Advancement Cost Engineering Estimating Standards, based on the current conceptual design that we have. And of course, those costs will be further refined as we move into whatever diversion structure design that you prefer. And we're attempting to keep them between these two, I'm going to call them sideboards. So that's what I have to present. I'd be happy to open this back up for questions and answers. I will stop sharing, but if I need to share back a slide, I will certainly do that.
Great, thanks, Alan. Questions?
I have a question. If, on the question, the need to divert in the winter, if we don't divert in the winter, are we just relying on Happy Hollow ditch in the lake? Is that our only sources during the winter?
We currently haven't been already, right?
Yeah, in the winter,
Based on the
months-
report.
I mean, in the winter months, it depends on the winter, but you know, so if the ditch freezes over, sometimes there's a little bit of flow. Joanne can answer this better than I can, a little bit of flow that makes it to the lake, but we don't divert from the lake in the winter. We rely on the Happy Hollow water. That's what you're asking.
Is that a pretty stable reliance? I mean, I know he's graceful recently,
In the winter months, yes, it meets the needs.
but there's no risk of him pulling our access to the Happy Hollow. In other words, do we need a backup? Do we need to build in a backup for the next 20, 30 years by engineering for diversion in the winter?
Why they for the winter?
Certainly could.
The LRE report talks about trying to divert water and getting it into the lake in the winter as a way to maximize or optimize our use of our water. So I think that's part of why we've been looking at whether winter is a good, getting more water in the winter would be helpful.
It would definitely be helpful, but as Alan was saying, we don't have a good sense on what that might look like if we did the infiltration gallery, what the amount of water through the alluvial might generate.
Plus you added maintenance. Potential maintenance of cleaning out the filters.
Right.
Got a few questions.
Okay.
I was wondering where Meridian is on this. Isn't that our contractor at risk?
They helped provide the opinion of probable costs. They worked with respect on the alternatives and those costs. Yeah.
And then do they weigh in with a preference, or is it just fairly obvious that it's alternative two?
I mean, Alan, do you want to talk to those conversations?
Yeah, so they were out in the field with us when we walked up and down the channel itself. I wasn't there, but our geomorphologist and several of our design engineers, our senior diversion engineer was there. We talked with them about pros and cons about location, about pros and cons about materials, looking at reusing as much as possible the large boulders in the stream itself to minimize the need to acquire and transport those boulders up through private property through the access road. They felt comfortable that we could build this structure at the location that we're proposing, and felt comfortable with the design assumptions that went into their approximate costs that they had provided to us. And I will mention that, at this conceptual level, we provided them some large scale estimates of the major elements in the project itself. But then we've added in contingencies for the smaller elements, things that we typically don't cost out at a concept design. We added contingencies in there for changes in estimated quantities as we move into design. We also added contingencies for unknowns, things that we don't think of right now or don't see right now that need to be in the design. And those were all included with Meridian as far as providing us an estimated cost and their preference for a location for building the structure. You know, they're a contractor, they feel that they could build it at either location, but are comfortable with our proposed alternative.
Thanks. I think it's probably obvious, but I'm guessing that the 800-foot upstream, although not feasible, was the best other alternative, would have been our best choice 3. So there aren't
It would-
really other alternatives other than the 2.
It would have been nice to be able to build it up there. Some of the cons that kind of eliminated it, one is it would require a change of point of diversion for your water right. That puts your water right potentially at risk if objectors look at it and say, oh, you've abandoned part of your water right. So that's a big risk of moving that far upstream. 2 is that, you know, it definitely would be more costly to run a pipeline up that whole distance itself. There's less knowns about that pipeline route. There appears that there may be some wetlands along that route, which would require additional environmental permitting risks. But, you know, it is another site that we looked at and thought would be a good site from channel stability and location standpoint.
My question was that there wasn't anything between the 200 feet up and the 800 feet up.
I apologize. There may have been, but there wasn't anything better than the 200 feet and the 800-foot locations.
Okay, yeah, that's it. And then one last question is there any plan to clean up some of the existing infrastructure if we go with alternative 2? I mean, without.
Yeah, that's something we certainly want to examine and work with Joanne and the town to say how much effort it's going to take to clean it out. What effort is it get to the pipe to that location? But certainly if we can reuse that to avoid some additional cost and get some benefits of what's already there, we certainly are very interested in including that as we move forward.
That's all I have.
My only question is, are we going to discuss the road piping and road alignment situations separately from the Grizzly alternatives? Because I think the intake alternatives seemed fairly clear and really well laid out.
The access road piece is a bit different, and
Okay.
based on conversations with the landowner, it's a good question, but right now, before you, it's just the diversion concept for us to move forward with.
Okay.
And I will add to that we've tried in these diversion concepts and alternatives to come up with ways to minimize the impact to the landowner and to the access road itself.
One last question. I assume the bulk of the cost is civil works and not so much materials, but on the materials side, is there any contingency built in for the uncertainty over tariffs, or is that so minor as not to be a consideration?
So it's pretty minor, only from the standpoint that most of the costs, like you said, is boulder type of work, earthwork work, which definitely doesn't have tariffs on it. So, you know, the Coanda screen may have a tariff, but it's not a large cost of the project itself. We're looked at precast concrete, which would be precast, a local precaster, which would not have tariffs. So there's not much of the materials that would be potentially subject to tariffs.
Anyone else have questions?
No questions?
My question is just, maybe I'm not understanding something, but in the executive summary at the beginning of the report, it lists everything in terms of highest, lowest, and middle risk, rank of risk for future failure, rank for maintenance, rank for disturbance. You're recommending that we go with all 2 with the infiltration gallery, but the addition of the infiltration gallery switches it from lowest risk to middle risk. Help me understand why we would want to do that anyway.
Sure.
Underneath.
So there's 2 aspects related to that. One is the risk of surface flows from going into the underflow itself and not be able to divert surface flows. So that is the one major reason why you may want to include the infiltration gallery. The biggest risk about that is that it requires maintenance. It can plug up. And
Right.
if you go with a passive or an active facility, either one of those requires additional maintenance and additional replacement that we think from a timing standpoint is more on the years of 10 to 15 years versus 40 to 50 years for the overall structure itself. So that is why we think the risk of failure, in the future is just from the clogging in that if you don't have the money or time to go fix it, then it's kind of a lost investment. As far as maintenance, yes, it requires additional maintenance, especially if you went with an active one where you almost are like backwashing to keep the openings there. And then as far as disturbance, we are disturbing more of the channel and creek to actually build that into the facility.
Okay.
And to date, we've only relied on surface flow for the 40, 50 years.
If the infiltration system failed, would it affect the operating system?
No, it would not affect the surface diversion or the conda or that type of diversion structure.
Higher maintenance and the strength of investment.
And it seemed like they were asking it to be included in case they need it.
Yeah, that's the other thing I was gonna say is that we won't know until we get in, and start digging, whether or not it's really necessary or not. Whether it's
Any subsurface.
even worth doing if there's not enough subsurface water, right?
Right. And so I guess.
Or I think, or is the understanding that we might accidentally increase the subsurface flows by messing around in that non-consolidated alluvium, and then that might in turn affect our surface flows the rest of the time.
That's correct. So we took a look and said, do we want to go up there and dig into this now, or do we want to wait? And our thought is, if we can wait, it'd be better to not disturb things up there now and then maybe create a bigger problem for us in the future.
So I was gonna say, any direction you all provide tonight, with a caveat that staff and consultant team be afforded some latitude based on all of that to pinpoint the best path forward, if that makes sense.
After further discovery.
Right.
Does the All2 Coanada screen, what is it? Coanda screen include the measuring equipment, or is that all in the third option?
So in our cost, the measuring equipment is included in the base cost that we have for the Coanda Alternative 2. It's just the telemetry that we put in there as an option.
I think All2 is obvious, and the infiltration thing,
We can see.
right? We're gonna need more information anyway.
One, I think, actually, one more question. I know we were considering the telemetry based on state of Colorado satellite availability. Are there ways to, if that satellite availability became higher or more available, or other things came online, that there's any pre-work that can be done in terms of conduit or pulling cables, or kind of pre-getting things ready? Like somewhere in the middle of not doing it and we can go full speed right now?
So let me answer that probably in a more simplistic answer. And that is, there's probably over 1,000 diversion facilities within the state. They're on the state satellite system itself. And the main reason is because it's the cheapest, most efficient way to get information. So you're not having to use cell towers or cell phones or that. The water commissioner can go online, immediately know what flow is being diverted. And the cost is fairly inexpensive for the state to have you on that system itself. So if there was a significant change in that system, you would be one of 1,000 people who would be complaining to the state.
Seems to me that telemetry is a given.
Yeah, I think that's where I was going.
Yeah, just real quick to reinforce that. Number one, it's best practice. Number two, the water supply assessment from LRE calls for that. Number three, the property owner, Wolf Land Company, would strongly recommend, or has strongly recommended, that we consider that. So
I don't, we shouldn't consider
What is-
this option.
what is Wolf's stake in us doing that? Just, I think we should absolutely do it. I'm just kind of curious.
Potentially lessen the amount of trips up there.
Okay.
We know, understand what's being diverted and
Okay,
have eyes on it better.
Yeah.
Obviously, their main thing is least impact on the parcel. Well, I think, it's been a really great presentation. It's a great, packet and, I think there's consensus that the recommendation is a good one and that, we need to leave some room for flexibility once we start getting on the ground up there, but it was excessive to do it at the 200-foot mark and do the Kiwanda.
You guys know, I always like some nodding heads. That'd be
Yes.
great.
I agree with John,
Yeah.
yeah.
I have thumbs up. You can tell by the way you can't see them. I also just wanted to say thank you so much for the comprehensive packet. I was really, really pleased to see that you had talked to the Colorado Wildlife and that you looked for raptor nests and did your true due diligence. That was really, really nice to see, and I just appreciate it.
Thank you.
Yeah, really, really comprehensive packet.
Preston, remind me, the $8 million loan that we have, is that likely to become a forgivable loan?
Yeah, I mean, we would only, out of that loan, it's interest-free for a 3-year period. We only use what we need. And, but your question's about forgiveness, and no, there's no forgiveness on what we end up using.
So it doesn't convert to a grant.
Correct. Yeah, that's a loan.
So that does put pressure on fiscal decision. But
Um,
not within this
You
range.
know, based on the opinion of probable cost, which again is very rough, and Alan gave a great rundown on minus 25% to plus 50%, that's a big range. Hopefully we can, fall within that number. And my point is the funding from the NRCS, disaster loan, disaster assistance from the state, technical assistance through the NRCS. I mean, we have some pretty good resources before we even we're gonna need to dip into that loan for sure, based on eligible costs and stuff, but I can tell you, looking at those numbers, that's not what I thought we would see.
well, and also in the vast scheme of things, percentage wise, those numbers aren't that far. And the answer is we have to just pick the best alternative.
Yeah.
Like
Well-
there's not really in that range a fiscal impact.
Also, with it being at risk, I would imagine they're gonna come in lower than higher.
And again, like,
I'm not comparing 1 million and 10 million. Like,
Yeah.
Yeah,
Exactly.
Great.
yeah. Great work. So keep it with.
Thanks, Alan.
Alan, Michelle, I think we have the
Thanks,
direction we
Michelle.
need.
Thank you. We appreciate the direction. Our next step is put together 60% plans by the end of this month. So we're on track now and are going to be very diligent to get that done. So we appreciate all the comments and questions and look forward to talking with you again.
Great.
Thank you.
Thank you again.
Thanks, everybody. Bye.
About this rain.
Yeah.
God.
I did not.
Check.
Tendency of food gets its name.
When it clears and watch the plants grow.
And then okay, there you go.
Yeah.
Named for Romanian inventor Henri Cohen.
How funny. And it's almost like Canada, which is where it comes from. I was like, sure it was like canola oil, Canadian oil company.
Thank you very much. Appreciate everyone.
All right, I will, unless there's any other business, we are adjourned.
Thanks, guys. Have a good night.
Thanks, Bob. Have a good trip.
Thanks.
Thank you for joining.
You bet. Bye.
Bye.